Okay, in the last couple of videos, we've been learning how to reverse differentiation. That is, if we have dy dx, are we able to find out what y is? And what we learned is that if we've got functions like this, where we've got x to the power of something, then we add 1 to the power, and then we divide by that new power. So in this case, we're going to get 8x to the power of 4, because 3 plus 1 is 4. We divide by that new power, and then we need to remember that we have to add a constant here, okay, as I explained in the last video. So if we simplify this, we're going to get 2x to the power of 4 plus c. However, what I didn't explain before is what happens if dy dx is just a constant value, that is, if it's just a number. So let's say we've got dy dx is equal to 5. How would we find out what y is in that case? Well, a way we can think about this is we can say that dy dx equals 5 is the same as 5x to the power of 0, right? Because x to the power of 0 is just 1. And if that's the case, then the same rules still apply. That is, we add 1 to the power, so we get x to the power of 1. We divide by the new power. Then we add a constant as well. So this simply becomes 5x plus c. Now, hopefully, you should be able to see there'll be an easier way to think about this, because if 5 becomes 5x, then what do you think will happen if we've got dy dx is equal to, I don't know, 9? Well, that will become 9x plus c. Okay, so why don't we just try a couple other examples, see how we go. Let's say dy dx is equal to minus 3, dy dx is equal to 27, and dy dx is equal to minus a half. What will happen to each of these? Well, basically all we do is we just add an x on the end. So minus 3 becomes minus 3x plus c. 27 becomes 27x plus c. And minus a half becomes minus a half x plus c. Okay, so now that we know that, we can hopefully attempt some other examples. I think I've got 3 more here to go through. So here we've got a simple one. So how would we reverse differentiation for this? Well, we add 1 to the power, we divide by the new power, we add 1 to the power, and we divide by the new power. And then what happens to this 5, which is just a constant term here? Well, that becomes 5x. And of course, we've got to remember to add the constant at the end. Okay, let's try one more. This one's a little bit more tricky. Why is it harder? Well, because we've got fractions here. And what we need to remember is we need to remember our rules of indices from the earlier chapter. That is, if I've got a to the power of minus n, this is the same thing as 1 over a to the power of n. So I can rewrite this expression as 3x to the power of negative 5 plus 2x to the power of negative 3 minus x plus 1. And then once we've done that, the same rules all still apply. So we add 1 to the power. Now, minus 5 plus 1 is not minus 6, right? A lot of people make that mistake. Minus 5 plus 1 is minus 4. I've got to divide by minus 4. Same thing here. Minus 3 plus 1 is minus 2. We divide by minus 2. And minus x, well, this is x to the power of 1, isn't it, right? So that becomes x to the power of 2 divided by 2. And the 1, well, that becomes 1x. I've got to remember to add the constant here. So now if I simplify all of this, this will become minus 3/4 x to the power of negative 4 minus x to the power of negative 2, because 2 divided by minus 2 is just negative 1, minus a half x squared plus x plus c. Okay, and that's our final answer. All right, well, let's try one more. What are we going to do in this particular case where we've got 2 brackets? Well, basically we just expand the brackets. This becomes 4x squared minus 28x. And then we just apply the same rules. Add 1 to the power, divide by the new power, add 1 to the power, and we divide by the new power, and we don't forget the constant. So if we write this out, this is 4/3 x cubed minus 14x squared, and plus the constant. Okay, guys, that's a little bit more on that chapter. I hope it was helpful. I'll see you again next time.